So Hatanaka-san, the next speaker, after graduating Kanazawa Institute of Technology, in year 2014, he joined a company called Speee. He was involved in the development of Uzo and the Red Data tools. So today his talk is about the Red Data tools development to make the machine learning by Ruby available. So I am Hatanaka. I'm going to talk about the current status and future of the Red Data tools in order to use Ruby for the machine learning. My name is Yusaku Hatanaka. My name on Twitter and GitHub is Hatapi, so please follow myself. And I work for company Speee, which is one of the sponsors. It's based in Roppongi in Tokyo, and I joined this company in 2014. So I do Ruby, but also I do Go and Python. In my company, the native ad distribution platform, Uzo, is the program that I'm engaged. And also I do the execution of the platform by Python. So today I'm not going to talk about Uzo, but if you have interest, please ask me in reception later on. So this is the agenda today. First of all, the machine learning of the Ruby. So I'm sure that you are writing Ruby, and I think you are hoping to do machine learning by Ruby. And I use a lot of different language. However, because I like Ruby, and I want to use Ruby for machine learning. But this is not only machine learning, but in terms of the data analysis, data coordination will become necessary. And when you say data coordination, probably you will remember JSON or CSV. And I often use CSV or TSV. However, for JSON or CSV, not just the file exchange, but they can be used for API request and response. And this is the example that I have. The CSV file read by Python will be now written by Python will be read by Ruby, and 5,000 line like simple file. And the writing Python takes 0.8 seconds, and reading Ruby takes 0.1 second. So now the data size is relatively simple, 5,000 lines, 5,000 rows. However, if you try to process a big data, like if you want to do the calculation in one line or one row, if you use CSV or JSON, you have to collect everything at once. And it takes a lot of time. In machine learning, sometimes they have to deal with millions of like big data set. And then comes Apache Parquet. Apache Parquet is a column-shaped data format, and like different from JSON or other things, it can take the data partially. For example, in the previous example, they can pick up the specific column. This is easy with Apache Parquet, and the other characteristic is the size is small. Parquet will store the data in each column. So it has a similar shape, and it can compress the data. And with these two features, the Parquet is able to process big data and store. The CSV example, the data coordination speed I want to compare here, like it's now write in Python and read in Ruby. Although file format is different, but everything else is same. The CSV took 0.8 for writing, and reading was 0.1. But with Parquet format, writing takes only 0.13 and reading takes only 0.04. So both writing and reading becomes faster. So now it's able to process big data, but not just being self-complacent. We just went one step forward. In Parquet, the data coordination with multiple systems has an issue because Parquet itself will compress the data, and in this processing, the coordinated part has to defreeze the data which was once compressed. If it's just 5,000, this is not much work. However, if it's big data, this overhead or delay will become significant. So the multiple system coordination, what we want to make sure the seamless data exchange. And then comes Apache Arrow. And this Apache Arrow is the formatting algorithm so that they can use the column-shaped data in memory. And they will put the data in memory, and the cost for serialize and deserialize will be 0. And the reception, receiver, and sender of the data do not use CPU. And another feature is 0 copy. So the receiver of the data do not have to use the time for the copying the memory. So with this, in Apache Arrow, the seamless data exchange is secured. So again, I compare the speed. The program is Apache Arrow, and everything else will be same as before. And the result is writing is 0.07 second, and reading is 0.007. And CSP Parquet Arrow, we compared in the summary next page. In this table, shows CSP and Parquet and Arrow. And as you go down, the speed will increase. So Arrow is advantageous in terms of speed compared to other format. And next is Apache Arrow. What's the position of Apache Arrow? So like Spark or Pandas or big data project are available in the world. And when coordinating those different projects, it has to be output in CSP or other things. Then it has to be processed as path. Because each system has different e-memory system. If it's 1 or 2, it's not going to be an issue. However, if it has to be coordinated with 3 or 4, this will become really become a mesh. And by using Apache Arrow, this will be streamlined. So I think you understand the advantage of Apache Arrow already. And then when you try to analyze the data in Ruby, what does Apache Arrow do? When you use the Ruby and Parquet, the data transaction in gray, the multiple system will be coordinated by Apache Arrow. And the Parquet will be used in and out. And by doing this, Ruby can process the data. This will make the data exchange possible, but we cannot still say that we analyze the data in Ruby. So however, if Ruby can use the Arrow, now it can be incorporated in a part of this gray area. So already Ruby can contribute partially. So not rather than starting from the scratch, they can start from the middle. Like after collecting data in Ruby, they can relay to the Pandas or Spark, and finally they can receive by Ruby. So like we can gradually transfer whatever was done in Pandas or Spark to Ruby. So by using this Apache Arrow, we try to use the do the analysis with Ruby, and this is red data tools. So this logo shows the status. like Ruby will be seen from the top. So by using Ruby from different angle, we will have another opportunity or possibility. That's what's shown in this icon. And now I want to introduce the project, Red Data Tools. The project was established by Mr. Sudo in a company called ClearCode in February this year. The objective is to provide the data processing tool by Ruby. So Apache Arrow, by using Apache Arrow, not only in Ruby community, however, it can be used in different community. And current activities in Red Data Arrow. There are 3 things. First is Red Arrow. So Apache Arrow, we are now trying to use by Ruby. And Apache Arrow is implemented on C+ environment. But now with Arrow glib and object introspection, we now achieve the binding of the Red Arrow. And we are now trying to make the existing gem to Ruby. So there are such projects like C-Ruby or Ruby Numo, like DAO, which can be used in the data frame or Numo array. These individual gems are existing, so we would like to coordinate them. And also the Parquet, which is generated or developed by Muraken-san. And by making them Arrow, the big data project, well, we can coordinate easily with the big data project. And thirdly, we want to propose or provide new tool. This is exactly what I have been working on. One of this is the development of Red Chainer. Chainer is a deep learning framework by Python, and this has been ported to Ruby. Not by finding, but we make the code by Ruby from scratch. However, the parameters we are referring to this chainer. So we are using the legacy class. And we use the Numo N array for the internal array. So now I'm going to show you just a screenshot of MNIST. The result of the MNIST execution is like this. And now, finally, I want to talk about the future of Red Data Tools. So, like Red Data Tools will continuously respond to the Apache Arrow of the existing gem. And also, we will continuously develop new tools such as Red Chainer that I'm working on currently, so that the data analysis will be possible between Rubies. And another thing is the development for Apache Arrow itself. I would like to participate. Because if we try to analyze the data only with Ruby, it takes long time. However, Apache Arrow with C++ language, then maybe Python users, when they add the new function to Apache Arrow, we can add a new function to Ruby. And if Ruby user develop new function for Apache Arrow, it can be used by Python users. So going beyond the barrier is our theme, and which will be easily achieved by doing this. And finally, this is the summary. So by using Apache Arrow, well, we can start from the necessary part, the data analysis of the Ruby using Ruby, and by making one step by step, we can use the Ruby for data analysis in the future. Finally, I want to give you an announcement. Net Data Tools have a monthly event, and it's posted in the Compass. So the location is in our headquarters in Roppongi. However, if you are interested, please participate our meeting. And if you think Tokyo is too far away to participate, our daily development will be done individually online using chat. So please participate from this URL. Well, we don't have the time to address the question today, but I will be present in the reception today or tomorrow. Thank you for your kind attention.